Good morning. Today we are going to see what is called as regular expression. So a regular expression is a pattern which describes the set of strings which matches the pattern. And the recursive definition of regular expression is given like this. So epsilon is a regular expression which indicates the language containing an empty string. That is, L of epsilon is equal to epsilon. This is the set of strings which belongs to the language. We are going to write it within the curly braces and it contains only the empty string epsilon. Next, phi is a regular expression denoting the empty language. So empty language is nothing but there is no string. Epsilon is also one string in epsilon, but phi, when you are considering, there is no string which belongs to the language. Now, x is a regular expression which represents the string x. So, suppose a is a regular expression, it means that language contains only a. If L is equal to b, which means that b is the string which belongs to the language. And if x is a regular expression denoting the language L of x and y is a regular expression denoting the language L of y, then x plus y is a regular expression for the language L of x union L of y, where L of x plus y is nothing but L of x union L of y, which is nothing but if suppose a is a regular expression, b is another regular expression, then the language of a plus b will be L of a union L of b. That is nothing but the first language, the language of the first regular expression union the language of the second regular expression. Similarly, this is called as the union operator, then concatenation operator, and this is the Kleene closure operator. So if xy is the regular expression which corresponds to L of x concatenated with L of y, where L of x into y is equal to L of x dot L of y. So it means if you pick one string from x and another string from y, then L of x into y will be nothing but L of x into L of y. That is the string concatenated from x followed by the string from y. Then R star is a regular expression corresponding to the language L of R star, where L of R star is equal to L of R whole star. And this we can apply these rules any number of times, and all those which are generated by applying these rules we are also calling them as a regular expression. So we'll see the precedence. Now, among the operators stars, concatenation and plus, star has the highest precedence over the concatenation over the union operator. Suppose example 0, 1 star plus 1. In this 1 star is having higher precedence, so 1 star, and again between dot and plus, dot has higher precedence, so this has to be first computed, so 0 dot 1 star plus 1. Next, how does this regular expression is compared with the finite automata? So, uh, regular expression represents the pattern of any string which you can accept by the finite automata. Suppose I have a finite automata for some language, then that can be represented by using what is called as a regular expression. Suppose here 0 1 star plus 1 0 star. It represents the finite automata which says that the language consists of 0 followed by any number of ones or 1 followed by any number of zeros. So this is a regular expression for this language. So every finite automata whatever I have, I can represent by using what is called as a regular expression. And your automata is a machine where it takes the input and generates whether that string is accepted or rejected. And whereas your regular expression is like the program or a syntax like statement. So where it represents, as I told, this represents the language 0 followed by any number of ones or 1 followed by any number of zeros. It's like a syntax. And your Unix environments uses these regular expressions, and even in your Perl scripting it will be used, the regular expressions are used, and even in the exec analyzers like lex and flex, they use the regular expression while matching for the string. So this is the diagrammatic representation where my regular expression is equivalent to the finite automata, and we have seen that your finite automata could be a DFA, NFA or epsilon NFA. So for each of the regular expression I have an epsilon NFA, and epsilon NFA or a DFA or NFA can be represented using the regular expression. So which are the representation for the regular languages. Next is we'll see the union of two languages. Suppose L is a one language, another M is another language. L union M will be containing all the strings which either belongs to L or which belongs to M. So union of these two languages produces a third another, that is another language. So union of two languages will also be another language. Similarly, the concatenation will be L concatenation by M is nothing but all strings are of the form XY, where X belongs to L and Y belongs to M. This is written without using the dot. Normally L and M, LM is nothing but L into M. Next is the Kleene closure operator. So where this Kleene closure is represented by L star. So before that we have to see the powers of the language. So L0 is nothing but empty string. L1 is nothing but a string where W belongs to L, and L square is nothing but W1, W2 such that W1 and W2 both belongs to L. That means you concatenate the two strings from the L, so you will be getting L square. Next, similarly, if I write L raised to I, it means W1, W2, Wi, where each of these Wi are from L. So your L star is nothing but the Kleene closure is the union of L raised to I, where I is greater than or equal to 0. It means that L star is nothing but L0 union L1 union L2 until some infinity. So it is arbitrary number of concatenation. If you do, you are going to get what is called as a Kleene closure. So let us see some example. So suppose L is equal to 1, 0, 0. So these are the two strings which belongs to the language L. Then what is L0 is nothing but epsilon, as we have seen that your L0 is nothing but empty string. Then L1 will be nothing but by taking any one string from L, whatever I get, that will be your L. So your L raised to 1 is nothing but 1, 0, 0. Next, L raised to 2 is nothing but you take two strings from the language. So I can concatenate 1 with 1. So I'll get 1 1, or 1 with 0 1 0 0. So I'll get 1 0 0, or I can concatenate 0 0 with 1. So I'll be getting 0 0 1, or I can concatenate 0 0 with itself. So I'll be getting 0 0 0 0 0. So these are the four strings which I can obtain in L square. Similarly, L raised to 3 is nothing but L square concatenation with L. So you have four strings here concatenated with each of these strings. You will be getting remaining strings. So you will be getting 8 such strings. So likewise, the union of L0, L1, L2, L3, L4, L5 until some infinity, you will be getting what is called as L star. So L star is L0, union L1, union L2, so infinity. So all these are the strings which belongs to the L star. So suppose some important note. So L star is infinite if the length of L is greater than or equal to 1. It means that suppose my L is containing more than one string and my L is not equal to empty string. If it is empty string, then I cannot say that it is infinite. At that time it is finite. But if it is not equal to empty, then my L star will be infinite, because if L, suppose if it contains at least one symbol which is not epsilon, then I can infinitely concatenate that string, that character with itself, so to get real star. So this length of that L will be infinite. My L is empty string. Then L star is just epsilon, because if I concatenate L, which is nothing but empty string, any number of times I get only empty string. So that's why L star will be only epsilon. if L is 5. So if you have no string, then L star will be epsilon only, because according to the definition, L raised to 0 is nothing but empty string. So L raised to 1 is nothing but 5. So you will not be generating L raised to 1, L raised to 2, but you have L raised to 0, which is empty string. Therefore, L star will be epsilon. So sigma star will denote the set of all words over an alphabet sigma. Therefore, the way of saying that there is an arbitrary language L over the alphabet sigma is L is a subset of sigma star, because in your finite automata we have seen that what is called as sigma is a string, that is a set of alphabets. So the language will be represented by the subset of sigma star. Now, how we can build the regular expression? By using the recursive definitions, or by using this concatenation, union and closure. Suppose L is a regular expression and the language by E will be L of E. Then the L of E will be equal to E itself. L of E plus F. This is L of E. L of E plus F is nothing but you take L of E and perform the union with L of F. Next, L of E F is equal to L of E into L of F. L of E star will be L of E whole star. Now, how do we use this regular expression and the language operator? Suppose we see the example. Suppose L is equal to W such that W is a binary string, means the sigma is equal to 0, 1, which do not contain two consecutive zeros or two consecutive ones anywhere. So both 0, 0 as well as 1, 1 cannot be together. In that case, suppose example, if you see this string, so there are no consecutive zeros as well as no consecutive ones. So which means that string belongs to the language, whereas if I see the second string, that is the 1, 0, 0, 1, 0, so it does not belongs to the L because it contains consecutive zeros. Now here the goal is to build the regular expression for this L. So we have these four cases. Suppose the case 1 is W which starts with 0 and length of W is even. This is the case 1. Case 2 will be it may start with 1 and it is even. It starts with 0 and the length of W is odd, and starts with 1 and length of W is odd. So we'll see for each of the cases how do we write the regular expression. So case A is it starts with 0. So if it starts with 0 and it has even length, then it has to be 0, 1 whole star, because you can have 0, 1, 0, 1, 0, 1. They have to be together only. 0 it has to start because it should not have any uh, consecutive zeros. So it cannot be 0 and it has to be 1 only. So it has to be the 0, 1 whole star. Next case is it starts with 1 and it is even. It means that 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. It has to be the repetition. So it has the this is the regular expression for the case B. Next is it starts with 0 and it is odd. The length of W is odd. If it starts with 0, then the next character has to be 1. And because the length is odd, so it is character 1 and it has to be followed by even length. Odd length and plus the even length will again form the odd length. So 0, 1, 0 whole star. The last case will be 1, 0, 1 whole star. I cannot have 1, 1, 0 whole star because 1, 1 cannot be together. So it has to be 1 followed by 0, 1 whole star. So these are the four cases that can be the split up for this string language. So your regular expression will be the union of all these four cases. Now if you introduce epsilon, because it can also contain epsilon string, so I can write it as uh, this regular expression. I can simplify it like it can, the first character must be either epsilon or 1, followed by it has to be 0, 1 whole star, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 whole star, and it could be ending with either 1 or 0. If it ends with 1, then this part I will take epsilon. If it ends with 0, I will take this as 0. So epsilon plus 1 into 0 1 whole star into epsilon plus 0 will be the final regular expression for this language. Thank you.